Hey everyone, I'm going to be doing a little bit of streaming today. I'm going to work on Sonic some more. Probably only stream for about an hour or so, but I haven't done much on my Sonic game for a couple of days, so I wanted to work on it a little bit. So I'm back at it. So I did work on it at the beginning of the week. I worked on it a little bit and I got animation starting to work. So you can see here I actually loaded up. Actually, I think the big thing was actually getting the Sonic sprite to work. So it turns out Sonic is actually made up of a couple of different. So we have the tiles. Remember that we had like the 8x8 tiles. And so Sonic is actually made up of a lot of those. So you've got something called sprite mapping, and so you have these 8x8 pixel tiles, and it tells you the sprite mapping tells the game where to kind of put the tiles. And so there's like kind of like a group of tiles here, and there's a couple of groups here. And so each sprite mapping has like a, what is it? Yeah, so sprite mapping is made up of, so it's got sprite frames, and then there's inside of that, I don't know, there's something. So anyway, it tells the positions of where the tiles are. So you've got like a group of tiles, and then there's positions of where those tiles are. And then what else did we do? There was so there's a dynamic load. What is a dynamic load? Dynamic pattern load queue. Uh, something a bit involved. What it does is it, when you go to load up the Sonic sprites, they're not actually all just in memory at the same place. What they like, a lot of the Sonic sprites are reused, and so they've got like something called a dynamic pattern load queue, which basically says reuse these tiles, reuse these tiles, reuse these tiles. So it basically says reuse this group and reuse this group and reuse this group. And the reason for that is so that the ROM is smaller. So basically, when you go to display a sprite, the way that it works is you've got to get all these sprites, you've got to get all these tiles from the same section. And a dynamic pattern load queue says copy these things into memory so that they're all in the same section. So it's basically so that the ROM is smaller. You have to kind of, when you go to load it, you have to kind of expand all these things in memory. So it's kind of, I guess it's kind of like a compression maybe. You basically get instructions on where to load things from and then where to put them in memory. So I did those two things. Those sprite mappings and the dynamic pattern load queues were two big things that I got working, and it means then I could add animation, and so that's what I've done as well. So I've got sprite mappings, dynamic pattern load queues, and animations all being loaded into the game now. The one of them is wrong. Which one's wrong? The sprite mappings is slightly wrong. There's a bug in there somewhere. Halfway through Sonic's frames, I had them all being displayed before, but about halfway through Sonic's frames, you kind of get like a set of animations, and halfway through the animations that I loaded, they got corrupt, and so yeah. I only have about half of Sonic's animations. But that'll do. I mean, I've got idle animation. I think walking is completely fine. There's a good group of animations that work well. So I'm happy with that. Okay. You can see out here I'm printing off. I've got this weird thing where I've actually kept the game's frames to be the frame. So an animation has like a delay, or like a frame rate, and so this is like, what is it, 5, it takes 5 frames, so the game is meant to run at 30 frames a second. That's like Sega Genesis, Sega Mega Drive is meant to be running about, I think it's 29.4 or something like that. There's some sort of, it's basically 30 frames a second. And this animation is meant to be 5 frames for every I guess, what would you call it, for every frame, every like new for every new sprite mapping is meant to take up about five of those. So it's like 5/30ths. So it's meant to be like 1/6 of a second, I think it is. That every frame of this animation is meant to display. So I think I've done that. I think I've capped the game to run at 1/6 of like 1/6. Sorry, 6 frames a second, I guess it is. Yeah, 6 frames a second or something. So you can see it's quite slow to move around in that, because I've capped it off at that. But yeah. you can see that it actually like it looks, so this isn't actually running at like, what is it, 1/5 or 1/6 of a second. It's actually a little bit slower. So like parts of the animation are faster than others, so like they've kind of duplicated frames here, so it's actually displaying a couple of frames. You can see here every time like this thing gets printed out, it's actually displaying a new frame. It's just that a lot of the frames get duplicated just because they want the animation to go slow at this point. I think if I run it, and I scroll down as quick as I can, I mean I've cut the whole game to run at 1/6 of a 6 frames a second, so it's quite slow to scroll down. But you can see here, the animation goes a little bit quicker than what it did before. So every time this is ticking, it's actually displaying a new frame. It's just some of the frames are duplicated. So you can see this is Sonic's idle animation. Eventually he like sits down or lays down and does that finger wave thing. But yeah, this animation looks completely fine. Actually, it seems to work. So you can see here, quite quickly sat down. So there's that. Anyway, so I've got that working. It's a massive mess, and basically the goal of what I'm going to do tonight is try and clean it up. I'll probably spend an hour and try and clean that up. So I've got it's a massive mess I've made, absolute massive mess. So I want to kind of abstract out what I'm doing here. I want to do so I've got there's kind of two layers of mess here. I've got the frame rate I'm specifying from this animation that I'm loading up. So the animation says, I think it's 5 or something that comes out. So I'm kind of doing that divided by 30 somewhere, I think. Do I have 30 in here? No. Maybe that's even wrong. That might even be wrong. Interesting. Anyway, so what I want to do is fix up so that the frames actually do run at, the 29 point whatever frames a second. Yeah. 29 point whatever frames a second. Actually, I've got a GitHub issue that actually specifies. I actually looked it up. Like, what should the Mega Drive run at? So I should know. Is my chat working? No one said hello yet. Here we go. Frame rate. I guess if me asking if my chat's working, no one will actually be able to answer. But please answer if it is working. So that's actually so it's 29.97 frames a second is what it is. And that's actually what the Genesis ran at in America. So it's actually different. Hey, how's it going? Thank you. Thanks for confirming. Yeah, so there's actually a difference between NTSC versus PAL. So I grew up actually playing the game on PAL, being in Australia. So the way that I played it is actually quite different from how most Americans played it. Or I think Japan was also NTSC. I actually think they had both NTSC and PAL. So that's a bit confusing. But the way I grew up, I played it on PAL, which had a different frame rate. So yeah, I never actually played it with NTSC, but that's what I'm gonna go for. 29.97. It's actually interesting because like Sonic was actually designed to be played on NTSC, was not really designed to be played on PAL. If you actually play the original Sonic on a PAL system, it's actually like 17% slower. So that's actually interesting. Like it's meant to be a fast game, but it actually runs 17% slower because you're on a PAL system. But anyway, we're going for 29. It's really interesting, like all the history behind it. But we're going for 29.97, like it was designed to go for. Eventually, hopefully this could be configurable and people can play it exactly like the PAL version, the slow PAL version, which no one would ever want to play it like that. But why not allow people to configure it to go 17% slower? Okay, so that's the frame rate that we're gonna aim for now. So we're gonna try and get rid of this dodgy frame rate thing I've got up here. So if I get rid of this and I reload, hopefully we should see everything go pretty fast. Whoops. just gonna specify this as int for now. Oh, I can't because it's, that's the problem. Okay. Okay, try again. The frame rate before was an integer, and now it's not. So hopefully we should see 30 frames a second. And now the animation is way too fast, so that's the next thing we're gonna have to fix up. But that seems to be like 30 frames a second, maybe. I'm not quite sure, but it looks like it. I'll put some logic in to do the delay and stuff. So I might actually wrap that up. So I'm gonna add like a function limit frame rate. Yeah, let's go like that. So given an IO and, sorry, given an int, so given a, actually double, isn't it? The frame rate is double. So given a double and an action to perform, then give back another IO. So the way that we did this is I used SDL. SDL's got like a tick, internal tick counter thing. Delay, is it? Yeah, I think it is delay. So this will get like the difference between when we started to do the action, when we so difference is going to be that. What is ntix? Word 32. Okay, I see. So we're doing from integral. Okay, I understand. Cool. Okay. So now I should be able to say, so now I've abstracted that out a little bit. So it should get the time, do the action, calculate the difference, and then delay appropriately. So if we're trying to hit like 30 frames a second, I should see it's basically limiting. It's going to be frame rate limiting. So we'll just keep putting delays in, which is probably not the best way to do it, but I think that's the way to do it in SDL. I don't think SDL's got really like any other timer stuff. Now I can get rid of this stuff down here because we've abstracted it out a little bit. Get rid of that. Get rid of that. Cool. Now I should be able to run it, and it should work exactly how we had it before because we just extracted that out into a function. Moving around. Hopefully that's 30 frames a second. Maybe it is, maybe it's not sure. Cool. I'm gonna trust that for now. If it's wrong, we can mix it up. Okay, so now we have this animation and we're going through it. You can see here like I'm kind of passing in like where is it? So this is where I'm rendering this sprite, and what I want to do now, I'm actually going to commit what I've got so far. I've extracted out the frame rate. Okay, and now I'm going to try and move this out. This is something else I want to move out. So this is taking a sprite mapping. Sorry, going through our sprite, getting out the sprite mappings and rendering them. So I want to abstract that out now. Now that I've kind of got the hard coded do it for Sonic, I want to abstract it out to a sprite. So I want to have like sprite. I want to have like a type that represents it. So what it does is it goes through, like, so I'm going through this loop thing, and so I've got this N and M. So for each step, it kind of goes through and interprets this animation script. That's something I should probably talk about. So animations in Sonic work like this. You have a script which is got how long. Hey Flyby, how's it going? Yeah, I've been really good. I've been busy. Hope things are going good for you too. Hey Taylor, how's it going? Thanks for dropping by. It's been a long time. I've been playing around with remaking Sonic in Haskell. Oh, something's gone wrong there. Let me load it again. So this is, I'm trying to make Sonic 2 but remake it. So I'm not emulating it or anything, I'm actually just remaking it. Come on. So this is reading in the original Sonic, like Mega Drive, Sonic Genesis, like cartridge ROM, and then getting out of the art, and then I'm basically doing the rest of it. So all the art is from the Sonic ROM, and all the rest of it, like the animation, like the actual, rendering and everything is in Haskell. So I'm happy. Awesome. So the way that animations work, they've got like a delay, like how many, because you kind of got like how many frames basically to wait between each animation step. So each animation step gets interpreted every so often frames. So this could be like every 1 frame, run an animation step, or every 5 frames, run an animation step. So this kind of is like how many frames to wait between animation steps. And an animation step is like to which frame you want to show. So like in Sonic, you can have like, when you have an animation, you've got like frame 0, 1, 2, 3, 4, 5. Like you've got all the different sprites you want to be able to show. So when you've got the idle animation, it'll just go like, usually it'll start off at 0, then go 1, 2, 3, 4. So it'll show each frame. Then you got reset, which will go back to the beginning. Jump back, where you can actually say how many ones you want to go back. So for example, if you go to the end, you might want to just repeat the things at the end. So if you can see when I don't know why it keeps finishing at some point. Maybe I've got some sort of problem here. No, it's not copy and paste and fixing bugs. No, I'm actually rebuilding the whole thing. This is all from scratch. I mean, it's reading the original source code and doing it from scratch, basically. You can actually get access to the original source code. Someone's like taken the ROM, decompiled it, and kind of annotated it as best they could. And so I'm kind of going through that and translating it over into a different, into Haskell, which is a lot more high level. So it's a lot more, it's completely different. So yeah, it's a bit of a challenge at times. Going from assembly to Haskell, they're extremely different, which is good. So you can see here, like, notice that he's doing like doing this frame over and over again. So this is when it does the jump back. So it says like jump back 4 frames or whatever. So it's jumping back. Animation next. So it can actually go for, like, if you're playing an animation. So for example, idle, you can actually go from idle to a different animation. And then you've got these subroutine things and routines, and I'm not sure what these are for. I have not figured those out yet. Yeah, so that's it. Yeah, so what I'm doing when I've got the interpreter, I am going through the frames, so it's just basically going through the next frames and just saying this N is like the index into the frames, and then M is like the next what would you call it? The next thing to show, I guess. Yeah. Going through the steps and saying go to the next one, and here's the next frame to show. So jump back, you can see that I'm saying go back J times, and it doesn't change what sprite to show. And then for the rest of them, I'm just not doing anything yet. So that's what I want to kind of move into its own separate thing. I want to be able to abstract out this. So I want each sprite to know exactly what which part of its animation it's done and which one to show next. So I want to kind of offload that into a different data type. So I want to have a data type like in sprites. I want to have a data type that says sprite, which has got a list of animation frames, which is actually an animation script, right? Yeah, animation script. So Sprite will have an animation script, and then it'll basically have an index into that script and current thing to display, basically. There'll be another couple other things as well, but that's a start. And that's what I want to start moving out. So I want to have basically Sonic be in charge of rendering himself. You'd have to have a how-to next to, yeah. I streamed this last week and got quite a few viewers from it, so it's actually going really well. Got hosted by, so someone else does Haskell, Ed Komet, and he hosted me. Well, he started streaming basically last week. He had 150 viewers the first stream, and then he started hosting me straight afterwards, which was awesome. So I had 150 viewers. It quickly dropped down, but yeah, it was a really good stream. So been going pretty well. So I want to kind of move this out, I think. I've been working on it for a couple of weeks, maybe 2-3 weeks, so not that long. I actually do get quite a bit done every couple of streams. Do get quite a bit done. Like, we really didn't have Sonic rendering a week ago, so it's going pretty good. It's going pretty quickly. Hopefully I don't get stuck. Hopefully I haven't gotten really stuck on anything yet. I've gotten stuck for maybe like 2 days. Trying to figure out like how sprites are rendering in that, but yeah, haven't gotten completely stuck on anything for like a week or anything yet. So hopefully it will stay that way, and we'll actually make a lot of progress. So I'm thinking this has got, one of them is meant to represent like the current state, like the current what would you call it, the current index into the script that we're at, and this one's meant to represent like the current frame that we're at in the sprite. So we need like a script and a state to be able to calculate a new state. So we've got a script. We don't care about the delay, but we do care about what is in it. So the steps, and yeah. So that's the index, and this is like the, I mean, it's also another index, isn't it? So one's like the index into the step index, and one is the sprite index, I think. Something like that. if someone hasn't done it before and written a detailed guide for me to read, it can't be done. Yeah. Well, this is your detailed guide. This stream is your detailed guide. Okay, so this will be, so this is steps, and this will be our new animation state. Okay, I'm going to comment this out, and hopefully this will compile. I'm going to open up my GHC ID. I like doing that. I'm going to actually open up my shell first, Nick shell. Don't think I have to do that, but I'm opening up a Nick shell anyway. Oh, I haven't got this cached. Oh, I didn't know the next channel update this morning. Now that I'm watching you, I'm an expert and can make Sonic 2. Easy. Easy. It'll only take you a couple of months like it's going to take me. What's going on there? Don't know why I'm getting a syntax error. Oh, I left a line uncommented somehow. I missed that. Okay. Not in scope, animation script, constructor, yep. Fixed. Animation frame, yep. Oh, animation step, isn't it? That is step index. Get rid of the ticks. We usually pronounce that prime in Haskell. Why is that? Animation steps. Do I convert that to an array somewhere? Yes, I do. Okay. Probably what I should do actually. Up here I should convert this into my bounded array thing. Which is my thing that I came up with, which is, I don't know, I'm kind of conflicted on. Like a lot of the things I make, a little bit conflicted on that. List array fill of animation reset. I'll fix up the, I've got this, I'm kind of wanting to get rid of this pattern match, this dodgy pattern match, but I'll leave it there for now. It's dodgy, but we'll leave it. Cool, compiles. Okay, so that's stepping the animation. And now I'm going to have a sprite which will have animation state and animation. That sounds good. So when we step a sprite, it is going to, what's it going to do? It is going to update our animation step. Yeah. So the script doesn't change, but the animation state steps one. Oops, I called step sprite. That's not what I want to do. I want to call sprite. And that's state. Cool. And sprite to sprite. No music. I used to have some music. I can put some music on. I used to play. Yeah, I'll put some music on. I've got Monster Cat. Sorry, I completely forgot about it for a while, so just let that go. Ignore that. Oops. There we go. So let me know if that's too loud. Hopefully it's not. Where'd my thing go? It must have come up on a different window. Sorry, different desktop. Here we go. It's back. We're not actually using that function we just wrote. Let me know if it's too loud or too not loud enough. I can change it a little bit. Cool stuff, Sprite. Cool. Awesome. Thanks for letting me know. Now we can do render sprite. So render sprite will take a sprite and render it. Like, I mean, ideally we could have two Sonics on at this, like two Sonics on the screen at once. That would be ideal. Hey, thanks for all the great content you put through on Twitch and Twitter. Still struggling with beginner concept though. Try following the FP course, but since it's not compatible with Stack, it's just too complicated for me to get going. All the people I know are using Stack, so why isn't Stack supported for FP course? Oh, it's slightly too loud. I'll turn it down. I'll turn it down a little bit. I teach FP course a lot, and every time someone's tried to use Stack, it's not worked for them. So I tell people not to use Stack. The thing is, like, Stack will get you a version of GHC, it'll get you dependencies and that, and you don't need any of that to work on FP course. If you want to just work on FP course, all you need is GHC. So if you go to if you go to Haskell.org, and you download, you just go to the minimal installers and you just get GHC. That will be enough. That will be enough for you to work on FP course. So you don't Stack is linked there, but you don't actually need Stack. Just use GHC. Just download GHC and you're good. Like, that's all you need to work on FP course. You don't need Cabal. You don't need. I mean, Cabal will come with this minimal thing anyway. But yeah, you just need GHC. So clicking one of these will give you exactly what you need. You don't need stack, you don't need anything else, you just need GHC. The answer for why isn't stack support for FP cores is because every time someone's tried to do that, it doesn't work. I teach FP cores over and over and over again, and no one's gotten stack to work for FP cores, so that's why it's not supported. So that actually so this will step the animation. Step the animation, but we only want to step on every based on the delay. So what's that mean? We need to pass in how many frames there's been. We need to pass in a count of how many frames there are, and every time it hits the delay, so I guess we could do modulo arithmetic and say that every time, like every nth frame, we step the animation. I think that's the way to do it. Let's go with that. I don't know. I guess we'll count frames with the word 16. I don't know, maybe may as well go 32, I guess. I don't know. Frames. So we don't want to step at every. Anyway, let's do step, and then we'll get it to render exactly how we've got it at the moment, which is like this. We'll do that first, and then we'll fix it up. But yeah, we want in this animation script, it actually says how many frames to wait before going on to the next action in this thing, the next step in the script. So we need to actually pay attention to that. We need to say how many frames has there been since the last time, and then increment. Okay. Anyway, so let's actually render this. So we need to pass in a renderer. I'm gonna need to start putting this into like I'm gonna start having to use like reader monad and then say that we're taking renderer, because pretty much all these functions are taking in renderer. Anytime that we've got like a monad here, or we're doing something with SDL, we're taking in a renderer. So I'm gonna add that into the monad reader configuration later on, but for now we're gonna keep going with this, even though it's really gross, but we're gonna keep going along with it. Renderer. Now we need T's, so Sprite will need to have textures. Actually, that's not even the textures, that's the Sprite mappings. Stack is the only reasonable way to get GHC. I'm sure Arch could get. One of the people that made FP cores uses Arch Linux, so and he definitely doesn't use stack, so there must be some way to get GHC. So I'm just putting in a little hole here. I'm just saying a list of units, even though no, that's not what it is. And this is where lens would come in actually. I think I'm gonna start running some lenses for things. I've got lens included, so I can do that. No problem. Okay, so it needs a sprite mapping of texture. And I need to give it X and Y to draw out. Comes with width and height to draw out. So that's cool. I just need to v2. I'm not sure what v2 is, so there's a command called info. That's really useful in Haskell. So this is telling me what v2. Okay, so v2 is defined in linear.v2. Okay. Oh, but it needs one more time. Ah, I see. So it needs to be a v2 of something. I don't know what this actually needs to be. So I'm going to say v2 of unit, and then it should say it needed a v2 of what? Cint. There you go. I like putting unit in because then you usually get good error messages saying, hey, I see unit here, but I wanted something else. So. GC is available in the repos for Arch, directly installable by Pacman. Yeah, there you go. It should be. So that's good to know. It actually is cool. So this is where to draw it. This is probably going to be information that I should put in the sprite, actually, isn't it? Yeah. What's the problem with the dynamically linked GHC? That's what I use for everything. The music does change. I've got it does change. It's Monstercat. Monstercat is actually a company that uses Haskell, which is why I've chosen. I don't usually listen to this type of music. It's not usually my taste, but the company uses Haskell and they support Twitch, so that's why I use them, because they've got two good things going for them. Okay. The music does kind of go through different artists and that, but yeah, it's just if you wanted to look up, it's Monstercat. They just does stream. They just play different music and that. But yeah, they use Haskell, which is really cool. Not for a lot, but they do use Haskell. So step sprite and hey, how's it going, Tess? Render sprite. There we go. These are not used. Why? These have got to be used. Why are they not used? Why does it say not used? Oh, I see, because it's the offset, right? So I need to actually add to those. Okay. Always get broken dependencies when upgrading different Haskell apps with dynamic link GHC. Okay. Well, you do just need a GHC. Like, you don't need to upgrade any dependencies, or you don't even need dependencies to do the FB course. Hey, Isomorphica, that's an awesome name you got. So that's left, and then from integral top plus y. Cool. Okay, I'm getting somewhere. What's the point here? What's the point? Oh, there already is a point. Alright, xy. Whatever. Probably just hide that, but whatever. Okay. So now I have the sprite, got mappings, XY location. Okay, let's go with this. I've got animation step. So every frame we're gonna step the animation. I'm gonna add some lenses in actually, because I mean this we'll get for free if I add some lenses in. So this is how I do the lenses in Haskell. I actually just write them out. I don't use template Haskell or anything. I refuse to use template Haskell. So you might find that a little bit strange, but that's how I'm going to do it. Sprite, animation state. I have used template Haskell to like what? There's reasons why I don't use template Haskell. And I can talk about that. Oops, 2, 1, there we go. I'm gonna bring up GHCID again, just so I get some errors. Cool. So the lens is not imported. That doesn't sound right. Well, it's not. I'm gonna start needing a little lens in a minute, so. Lens is basically my prelude, like I said last time. Lens is basically my prelude, so. So I need to sprite to animation state. Animation sprite, and then our animation state. There we go. So we don't need step sprite, we just need to export, what was it? Sprite animation state. No problem. This is a fun thing to stream and also make sure that I actually work on this because I really do want to get this really do want to get this working. Okay, cool. Okay, I'm just making sure that still still runs in that, but I don't think I've changed anything in main, so it should run. There's no, yeah, I didn't change anything in main, so okay, I shouldn't even be bothering running it. Delete that. Okay. Yeah. Let's go with this. How does one learn graphics programming? What resources? I'm not really doing much with graphics programming. I'm mostly doing SDL. Well, I mean it is graphics programming, but it's like SDL stuff. So it's like SDL handles a lot of this stuff for us. So it's like just reading the API of SDL, using the types, basically coming in, actually going into the haddocks. There's a library called SDL2. If you come down here, actually if you look at the thing it says here, it's something about like SDL contains high-level bindings, the raw contains almost one-to-one translation of the API. So you want to stick to the SDL namespace, the high-level stuff, and ignore the raw stuff unless you need it. I don't think I've needed it yet. But here, SDL.video, and that's got lots of good stuff. So it tells you how to create a window. And using the types, you actually get directed towards the solution on how to create a window and what configuration there is in that. So it tells you how to create a window, and then you've just got stuff like there was a little bit that I had to learn, which was I'm not very good at graphics programming, but one thing I did know is that like I did learn from this is that there's difference between surfaces and textures, and surfaces are software stuff, textures are hardware stuff. So there's a difference between that, and that's important. But yeah, that's about it. That's basically all I know. Basically that you've got software rendering, hardware rendering, and Windows. And that's about it. Everything else I've just found out from the API. I haven't done a huge amount of graphics programming, so it's like it's basically just reading this documentation and trying things out. Where do you build security into your code? I'm not sure how to answer that. I don't know what. I'm not sure what that means. Okay, so I'm gonna make I'm actually gonna make a sprite that does all of this. So Sonic equals a sprite. And what do we need to do in this? We need to have the sprite mappings. Oh, it's down there, isn't it? do a little bit down further. So there we go, Sonic textures. Okay, so we've got the animation script, we've got the mappings. Is it mappings? Where do I get the textures from? What's going on here? I'm lost here. What do we have? So we've got sprite mappings. Okay, so we do pass in mappings. But where do the textures come from? Interesting. So T, render sprite. Oh, there we go. I see. So here we don't want the mappings, we want it's like a list of a list. That sucks. When did I switch to Spacemacs? It was probably about 2014 or so, somewhere around then. Somewhere around 2014. I had like a customized Emacs in that, but I don't know. I came across Spacemacs, and I was thinking about like switching over from the Emacs key bindings. I didn't really like them, and people always went on about Vim key bindings being better or whatever. So I gave it a go, and I realized that it actually kind of had better integrations than what I had set up for myself. So I switched over. I did lose a couple of things, but I kind of got them back now. So. My integrations also only half work all the time, no matter what I use, so I'm happy to switch. But yeah, I've been using it since about 2014. Somewhere around there, maybe early 2015, late 2014, I reckon, somewhere around there. It was basically around the same time I switched over to using NixOS as well. I'm pretty sure it's around the same time. Sprite's not in scope because I didn't export it. It's saying here what? I don't expect sprite frame. Ah, okay, it's a sprite frame. List of sprite frames, okay. Sprite frame of texture, isn't it? I think sprite frames are parameterized on what it contains. Problem I have when I have package panned off for general use, stack to develop Haskell code in isolated environments, and vanilla JC for FB cores. Sounds like you want Nix. Nix can do each of those all at once. Yeah, sorry. But yeah, Nix. What's going on here? This isn't even giving an error. No, because I've got like a kind error. Okay. Yeah, because I've got distracted halfway doing this, sorry. Sprite frame I need to import from Sprite mappings. Okay. Sprite frame. No, accessible list. Okay. So I do need what I had before. What do I have down here? So I'm accessing the textures and I'm saying give me the nth1. And then what am I doing with that? I traverse it. How am I traversing it? I don't get that. So what is Sonic textures? Let's go back. Let's keep going back. Ignore this. Let's come back to where we were before in our sprites, which is a sprite mapping of textures. Main has got, where have I screwed up main now? 153. Alright. So I've got this animation script. So this is not great, but I'm just trying to get it compiled so that, yeah, we're back where we were. Okay, cool. Back where we were. What I want to know is, what is this Sonic textures thing? So I'm just going to say, give it type of int, and it should say, okay, now it is a list of sprite mapping. So I don't know what was going on before. So I should be able to say let Sonic equals. Isn't that what I've got? Oh, I've got Sonic mappings. Oh, I've been just writing the wrong thing in. That's all I've been doing. Oh, that's annoying. Okay, that was... Okay. Cool. Okay, that was the problem. I was meant to type in Sonic textures. I was writing in Sonic mappings because I got confused. Okay. Types told me the right thing to write. Okay. So I need to have a location. I'm going to say v2 of 0 at the moment. No, that's not right. But animation script there and animation state. So I need an empty animation state. Cool, so I've got Sonic. Oh, I needed to supply that one actually. Empty animation state. Cool. So Sonic is a sprite. And now I should be able to say, get rid of this stuff. Get rid of that. Get rid of that even. And say, let's render sprite. And Sonic. Is that it? I'm just going to get rid of this stuff that I was passing in, which was the current state of Sonic. Actually, what I need to do is pass that in, actually, don't know. So let me pass in Sonic. You can barely hear me over the music? Oh, I'm sorry about that. I'll put it down a little bit. Is that a bit better? Am I using modal editing, Vim key bindings for Spacemax, or is the modifier chords all day? No, I'm not using mod. I actually did intentionally switch over to using the Vim key bindings. Yeah. Sorry, some people saying that the music's all good, and some people saying it's bad. So I'm sorry. Hopefully it's all good now. Okay. So hopefully this will do something. I don't know what this will do actually. Because we're not actually incrementing it. So it'll probably just show me the first frame of Sonic. I'm guessing. Let's see. No, I don't see anything. There should be. I think I've positioned him at 0, 0, so it should be up here somewhere, but I'm not seeing him. So that's not good. Yeah, that's not good. That should be working. From my understanding, I think we should see Sonic somewhere on the screen. Yeah, we should see him somewhere. I have used the gloss library, it's really cool. It's awesome, yeah. I was using it for, I implemented tic-tac-toe as well using the gloss library. It's very good. It's very good. Actually, I can show that real quick actually. It's a cool thing to show. Should better show it real quick. What was it? It was gloss. It'll take a second to download gloss again. I don't have it installed anymore, but take a second. I've garbage collected it at some point. I actually updated Nick's channels this morning, so that'll be the reason why it's not cached. So I'm gonna step Sonic in a way. I did have a gloss one. Oh, there we go. There we go. So this is tic-tac-toe using gloss, and when you press, you can see that, yeah, I did a quick thing. It was red when whoever won, and that's it. And then you can restart the game by exiting and doing it again. But yeah, it's really cool that it's really cool how easy gloss is. It's super straightforward to do this. Really straightforward. Really good. I have no idea if it's able to do nice fonts or anything. I have no idea. But what's cool about gloss is that everything's like pictures form a monoid, so you can just append pictures together. Really cool. So you can see here I'm using semigroup here, so I'm using semigroup append, just appending it all together. And that gives me a picture. It's really cool. So here's how to make a cross. Make a line from top right to bottom right. Sorry, top left to bottom right, and then here from bottom left to top right. So it's like just append those two things together and you get your picture. Super cool. You just append everything together and you get a thing. It's really cool. Really cool library. So I'm gonna modify the animation. No, what is it? The sprite animation state. But I want to modify the state. Which one do I want to modify? What is it? This is the step index. Yeah, picture has a monoid instance. That's how you compose all the images together. Really straightforward and nice. I mean, it makes sense if you think of pictures as a monoid, and it's just really nice to work with. So I'll probably change these at some point over to what we call classy lenses or classy optics. So I'll probably change that over eventually to that. What is this? +1? That's not it, is it? It's a plus. Maybe it's that. I think that might be it. What's happened here? Sometimes I accidentally delete code, I'm not sure why. So that code's got deleted somehow. There we go. Thanks for coming by, Taylor. It's awesome to see you again. It's awesome. What I'm going to do is actually derive odd show for all of these data types, and I'm going to print them out each time so I know what the hell's going on right now, so I don't. I have no idea what's going on. Why not gloss for Sonic? Because I think, from what I know, gloss is more, it's not really for, not really for graphics like this. It's more for like vector graphics. Maybe we could do like a vector Sonic, but it is possible to do non-vector graphics using gloss, I think, but it's not really optimized for doing that. So that's why not gloss for Sonic. I don't think, I think it would not be performant at all either. It's not really well made for doing pixel graphics like what we're doing. SDL is really made for this sort of stuff though. Okay, so I can't have show for a sprite. So I'll have to just get parts of it out. So if I can print that out, yep, cool. So let's run it, and we should see every frame. We should see, hopefully, we should see the animation step. Hopefully. Actually, I did something wrong there. I exposed this animation state thing as stepping the index. I actually don't want to do that. I don't want to do that. I actually want to say, I forgot that we actually wrote a function for it. So step animation state, is it? Step animation state? Just step animation. That's what I wanted. The script. Ah, I see. That's what we had before. Okay. So we did have step sprite before and I got rid of it, but I shouldn't have because it actually did do something important, which was it reused the animation script. So it will look something like, so we'll change it with the So we need to use the script to be able to figure out what to do with the state. So then I'll use Sprite and I'll get out the Sprite animation script. Okay, type checks. That's what we want. So we want Sonic step sprite Sonic. Okay. So that array is a little bit annoying, but that's what it is. Let's run it again. What I'm using to handle the raster graphics is I'm actually just rendering them to STL textures, which are like I've got surfaces which are like the 8x8 pixels, and then I combine them all up into textures. And a texture is like a hardware thing, so it actually loads up like bitmaps on hardware. So I'm actually generating the bitmaps myself, just using like red, green, blue data. It's actually interesting because it's not actually red, green, blue. It is BGR. Yeah, BGR. I like working with SDL through Haskell. Oh, there we go. I do actually have Sonic rendering. Cool. I don't know what I changed, but Sonic is rendering. Cool. It's working. I like working. I mean, if I'm going to work with SDL, Haskell is probably the best tool for it. There are a few problems with SDL. It's designed for like a very imperative API. So there's a couple of problems around like. So there's locking, which I don't like. They try and provide a high-level API. I'd like to see something more like instead of locking, like maybe like a higher-order function, you pass in something to do with surfaces, and it locks and unlocks for you. So there's a little bit of a problem around there. There's also I don't know. There's state vars. Yeah, these state vars are awful. And there's like so I've got this renderer, and when I want to render a surface to a texture, you have to set the global renderer. There's like a renderer state var. Default renderer. No, it's not that. There is a state var somewhere, which is the renderer. Like, what renderer do you want to use to render this surface? Yeah, render. So it's a renderer render target. Oh, it's the target. Sorry, it's the target. So there's global state to say, render this tile. So actually, I think it's actually rendering like a texture to another texture. So if you want to render like you've got like a little texture and you want to render it into a bigger texture, you have to set this renderer render target, and that's just a global variable. So you've got this global mutable state that you have to set to be able to render. So SDL kind of sucks in terms of an API, but if I'm going to use SDL, I'll use Haskell, because then this is the way that I set the global mutable variable. It's just a nicer way to do it than any other tool. I think it would be possible to make a better Haskell API for SDL and make it faster. I think it would be. Okay, so I'm actually going to delete this printing because we've actually got this working. It actually does print Sonic, so it actually does, like, I mean, he's stuck at 0, 0 pixels and that, so I'm going to have to modify that a little bit, but... yeah, he actually is there. He is there. So there's a couple of things I guess I need to do. I don't know what I should fix first. Like, should render, and I'm not sure if what the API should look like. With render sprite, at the moment I've just got a renderer and a sprite, and it goes off and renders it. And the sprite has like an X and a Y location. But maybe this main function should also have an X, like should pass in its kind of like global coordinates. Maybe that's what it should be here though. Maybe I do need to change this into like a game state. Maybe we shouldn't call it state, I'll call it game. So I'm gonna make a data type that represents like the state of the whole kind of global game type thing. So it'll be like the X and Y position of the camera. renderer. So now we'll be able to stop passing the renderer thing around. Okay. I'm a bit concerned that the display keeps going a bit weird every time I leave it running. I don't think it used to do that. Would it be better to represent the camera as a V2 Word 8? Probably actually. Why not? Let's go with that. Let's start off with that anyway. Because it's not even Word 8, and you've got a good point, because it's actually V2 of Cint. So, that's actually pretty... It should probably be better. That's in foreign C types. Let's go with that. We'll see if that works. Now Sprite, we'll be able to take render Sprite, and I'm ideally we'd be a little bit more granular than this. Instead of saying like we're taking a game, it'd be good if we could say we take in something that has a renderer and something that has, you know, coordinates, something that has like a position, a camera position. But we're going to start off with this. It's always good to have something rather than something perfect. So, what kind of shell? This shell? Are you talking about my terminal emulator or my Nix shell? Is that what you're talking about? It's always good to put some code down, even if it's not great code. At least you're making progress towards something. And we've made quite a lot of progress, even if it's not perfect. At least Haskell makes it super easy to refactor things. Yeah, Nix shell is so Nix is like a package manager. And it's also a programming language for specifying packages. So Nix shell is like a... Oh, okay, you thought it was ZSH or something. So this is ZSH, but then when I type Nix shell, it actually starts up a bash with all these things on my path. So I can say -p, I don't know. So this will download the .3 package and then give me a shell that has .3 on the path. So if I do this, I'll be able to access a program called .3. See that it came from there, so I just downloaded .3 and gave me access to .3. So now I can say .3. So I don't know if you know much about Nix, but it's just a nice way of basic package management. And it's actually there's some theory behind it, and it's actually a purely functional package manager, so it's really good. So when I just call Nix shell, I've got something in here. I've got this, and this is a specification of how to build my Haskell package. So if I run Nix shell, it'll go off and give me all the dependencies I need, and then I can run gcid or Cabal or whatever I want, and it will have all the packages I need to be able to develop. Need to get rid of your Mac. Mac can actually run Nix, so if you wanna use Nix, you can actually run Nix on Mac, and it actually works pretty well. Okay, yeah, so we can see here it says no instance for game IO. So we're gonna have to call it when we go back to main. We're gonna have to run it. I need to go run T. And to do so the underscore. When, I've done this quite a bit on my stream, but when you start a variable with underscore, that just tells GC to give you a really nice error message. And this error message will say found hole underscore to do. So this underscore to do, I need to replace it with a value that has type game. So I need to put like a game in here. So that's what I'm going to do here. I'm actually going to say game. I'm going to update it all the time. When we start off, we're going to have a game of zero. Will that work? It might work. I think there's like an overloaded numeric thing, so I can just say 0, I think. It needs a renderer though. And then, okay, cool. So we've got a game, it starts off 0. That's where it starts off. So the next one will be game renderer. Oh, we've actually got this O and we've actually got this here, so we can actually get rid of that. I'm going to get rid of my collision stuff for now. Because that should mean... the chunk textures, I need to update that as well. Okay. Okay, that's fine. So I'm getting rid of the collision stuff. The collision stuff has not been very useful at the moment though, because we're still trying to render things, so we can ignore that. This could be done nicer, but again, we're just gonna keep moving. Keep getting things rendered. That's the most important thing. Okay, so compile. So I don't know if this will actually, maybe I did enough that will work. Actually, don't I have to? Oh, I actually have to use it in here, don't I? That would help. So I should better. I'm actually going to write a lens to get the camera. It is where that is where v2 is coming from. It is coming from linear. It is linear dot. So if I import SDL and I say info v2, you can actually see that it says defined in linear.v2. So the STL is just re-exporting it. So it's actually getting re-exported. We can see that probably somewhere up here. We should be able to see. If we search for linear, it should come up, I think. Doesn't come up. I thought it should export. Oh, it's probably re-export from one of these, right? So one of these will export somewhere. I don't know where, but somewhere. One of these will re-export the linear thing. So STL exports all of these things. If it's in vect. Yeah, here we go. Module linear. So it actually, so STL.vect exports a chunk of linear. That's where it's coming from. So it is actually the same thing. It's just a re-export. So it's just, you can import it from STL or you can import it from a linear, but they're actually exactly the same type. And you can use them interchangeably. And what was the function we were using before to get like we had it, didn't we? We were talking about it. Was magnify, was it? I can't remember what it was. There was a function we wanted to use to get out the wasn't magnify, was it? The point vector distinction from linear would be useful. I'm not sure. I don't know. Is there what is that distinction? No, it's not this. It's not this. What is that thing? Was this operator for monad state? I thought there was one for monad reader too. I'm sure there's one for reader. I'm basically trying to use a lens to access. So we've got this monad reader a game. I want to be able to access a part of this game. I want to be able to access the camera of that game. Because then I also want to be able to say dot X and actually access, like, you know, the X part of that camera. Preview. Why can't you just use preview? Can I just use view? Oh, I've already. Defines a pointer as a handy wrapper to help distinguish points from vectors at the type level. Oh, okay. I'm not sure what that means. Cool, okay, that did actually do something. Okay. I mean, ideally we'd actually be able to do that on a point. That would be cool. So ideally I'd use template Haskell to generate this, and I've actually had a script before to do that sort of thing, but I don't have it working at the moment. I should really invest the time in getting that working, because it was a pretty useful script to be able to like use template Haskell to generate it and then just copy and paste it in. game renderer is going to be the next one. So I can delete that. So there's no more passing in a renderer. Getting there, making progress. Actually abstracting out some of the, like I've just hard coded like what Sonic does, and it'd be cool if I could have like 2 Sonics, because that would mean I'd have, maybe I could, maybe the next one I should do is Sonic and Tails standing next to each other, because then I've kind of shown that that we can have multiple sprites being displayed at once independently. I think I will do that. What's happening here? Scope. Okay, that type checks. Oh, my problem must be in main. Okay, yeah, main. What's the problem with main? 158. Oh, because it's not passing in renderer there. I don't need to. Cool. So this should still, hopefully, I'll have a Sonic idling up. Actually, yeah, because we're not actually using it, are we? We're not actually using it in our sprites logic here. That's the next thing to do. So we need to go take O and then take P. So hopefully now, when I move around, Sonic should like stay in his spot. So if I press up, he should shift down. So he's like in his staying spot. Okay, well that's close, but not quite. He's moving around quite a bit. He actually moves up and down when I go left and right. He does stay. I must have done something wrong there. What did I do there? Seems to be right. Camera Y. Yeah, that seems to be symmetric at least. Yeah, it seems symmetric. Not sure why the game doesn't close off either. It's a weird thing where it's not closing off properly for some reason. I need to fix that anyway. So he is shifting up and down, and when I go left and right, that is weird. That is weird. What's happened there? That's weird, isn't it? When I go left and right, he goes up and down. He goes up if I press left. Goes down if I press right. Did I screw up my lens? Because I've copied and pasted part of it, and I'm probably screwed up my lens. I did. There we go. I screwed up the lens. There we go, that's an easy fix. Ideally I'd be like writing quick check properties for all of this so that I would actually verify the lens laws, because I wouldn't have passed the lens laws, and so I would actually say, hey, you've written a bug there. Like, ideally I'd have tests for all this, and so I wouldn't even be having to screw around with manually testing things out. There we go, he stays the same place. So I've said that the sprite is at 0, 0, therefore he stays at 0, 0. That's not bad. When I quit, it's not actually quitting though. That's interesting. It's not actually stopping the game. It sits there until I quit it, or when I actually kill it, which is interesting because it shouldn't be doing that. Unless it's got some. Yeah, unless it's got something to do with what I've done here. Should run the action and then Oh, but I've got recursion here in my action, so my action keeps calling the limit frame. Oh, that's the problem. Yeah, my thing was dodgy and it didn't work. Okay. Okay, that's the problem. Yeah, my limit frame rate thing is super not good. Okay. I'm gonna work around that a little bit for now. I don't really like this, but I'm gonna do it. Okay, so what this will do is it'll when it's called, it'll figure out the current ticks, and then it will give back a function that will get the current ticks, calculate the difference, and then do a delay. So basically, in here, when I call limit frame rate, I'll get access to a delay function. Wait for. Now, here, I'll be able to say, wait for the frame rate, and hopefully this will work. I don't know, I think I'm writing things I'm not sure it'll work, but I think it might work. I'm not 100% confident, but I think that's the right thing. Okay, there we go. You can see it's slowed down a lot as well because we're not just infinitely recursing. Okay, so it is actually this is actually 30 frames a second. This actually looks more like 30 frames a second. Before it really didn't, and now, yeah. And now when I quit, it actually quits. Okay. My code before was completely wrong, and this is a lot better. Cool. So that's 30 frames a second. Sonic is doing his thing. I need to update that so that he only does that every, he's got to count every however many frames that he has to wait for. But cool. It's actually doing something cool. I'm happy. Okay, so it's waiting. Okay, that's pretty good. The next thing would be to to add a Sonic, add Tails in there as well. So we'll have Sonic and Tails. That'll be cool. And also, actually, maybe instead of game here, maybe we could actually add a list of sprites. So to render, so we could actually say go render yourself. So instead of having, and also in sprites, I could also have a level, render the level, render the sprite. So I could actually just say render game instead of render. Instead of doing all this here. But anyway, that's something to do next. Right now, what I want to do is make Sonic actually display at the right frame rate. He should he should only update every five frames or whatever. I can't remember what his actual script says. We can actually figure that out pretty quickly. It's animation script. I think it's 5 or it's 6, or something like that. It doesn't really matter when we actually go write the code, but I'm just interested how many frames he has to wait. 5. So he waits 5 frames. Cool. Well, I'm not sure what's happening now. It's not very happy. It's not rendering anything. What's happening now? I'm gonna try that again. Something's weird. What did I touch anything? No? It's back to where we were. I hope I didn't break something just then. Sometimes this happens. I'm not really sure why. But doing a clean fixes it. I think maybe there's two GHCs running. Like I think Emacs is running a GHC, and then this is running a GHC, and they kind of start overrunning each other or something. Something weird happens. Okay, there is nothing being rendered. Why not? It was just a second ago. I'm sure I haven't touched anything. I didn't touch anything, right? Okay, it's being rendered again. I just restarted. I don't know what's going on there. Everything's fine. I'm gonna commit because weird things are happening and this does seem to work, so. Okay, so we're gonna make Sonic actually wait the number of frames that he should wait. So what do we have? We had step Sprite, which would just step the animation script every time. But I think what we want is when does it need to increment? So I'm gonna make it so that yeah, I'm just gonna add another count. I'm just gonna add a count. I'm not using anything like Fork.io, no I'm not. That would actually make some sense if things are going weird because of Fork.io somewhere, but yeah, I'm not. Yeah, GHCI does some weird things, yeah. With Fork.io and that, yeah. So this always needs to be +1, so I probably should put that somewhere else. Probably should stop using word 8 for everything as well. Probably should have like, you know, actual types so that I don't get confused between them all. Because I often do hole-driven development, and if I've got all the same types, then they'll fit in all the holes, and that's not great. Right, but what I need to do here is that, right. This is what I need to do. So I need to say, actually these all need to go to 0. They all need to go 0 because they've all... When you run a step, you actually have to reset it to 0, so that makes... Otherwise, just return the original. Okay. I wonder if that'll be enough, actually. That might be enough. Let's see. Actually, where am I incrementing it? I'm not incrementing it though, am I? Ah, that's what I need to do. That's what I need to do. Okay. Okay, so we've gotten up to the delay. So like if we start off with 0, we go 1, 2, 3, 4, 5, greater than or equal to delay, then we go to the next state, which will reset it all back to 0 because we've actually incremented the state. And then otherwise, like if we're less than that, then we just keep going up in the count. So it should count up to 5, reset, count to 5, reset, and so on. What's the problem here? Sprites. Line 79. So yeah, this should, hopefully Sonic will animate at the right pace, at the right, like every 5 frames he should animate rather than every frame like he was. It's doing that thing again where it's like, it's loaded, it's colored things, and then nothing. It's weird. That is really weird. There we go. Now it stopped rendering. Why? Is it my delay thing? It might be my dodgy delay thing. Maybe I need to get rid of my delay thing completely. It doesn't seem to be working as well. I'm going to print out. I'm going to print out how much it's going to delay, and hopefully it's not saying like I'm delaying for... Maybe that's what it's doing. Try and delay for like... Because I'm doing this division thing, maybe it's saying like the frame rate. It's making a massive number here. That's probably what it's doing. -3. Yeah, okay. So there was -3 ticks between the start and the end? That doesn't make any sense. That doesn't make any sense to me. So it comes in here, it says limit frame rate. So that's when it will get the tick. What's probably happening is the first frame probably takes a while, and because I'm dividing by, yeah. Oh wow, it's actually, it is actually animating at the right pace. That's actually at the right pace, that's awesome. I think that's the right pace. Like, I mean, I haven't played Sonic 2 in a long time, but I mean, that looks about right to me. Cool, so I need to fix this bug where it's like -3 delay. I don't know what STL does with a -3 delay. It seems to just hang, so I need to fix that. that. So I think what's happening is at the first frame, because the lazy load, like there's lazy I/O going on, so it's like loading in some files lazily, and then when we go to render the first frame, it's like actually forcing the things, and so it takes a while to actually load the first frame. So the first frame, no, I was wrong. It's still broken here. It's still broken for some reason. What is this gonna print? There is definitely a problem with this delay though. I'm pretty confident that it's this delay. So this is 0, so it's going to delay 0. Is that a problem? Is it, can you not do a delay of 0? Does that just mean infinite? Delay forever? Let's go 1. I don't know. Whoops. Go 1. I don't know. Hopefully STL just doesn't hang forever if you say delay of 0. Well, it worked. But sometimes it does work, so let's try it a couple more times. It seems like it mostly happens and it's rarely it doesn't happen, so we'll run it for a couple times and see. Okay, so 2 in a row and it's not happened yet. So I think I'm right. I think STL is seeing 0 as delay and just delaying forever. Actually it's, oh no, there you go. It's happened again. Okay, so I was wrong. It's happened again. Why is it happening? Yeah, so it's not the delay. It's not the delay. Interesting. I'm actually gonna go put this back in here though, because I have a feeling it is this delay code. I might be completely wrong, and maybe it's nothing to do with this. Maybe there's some other bug somewhere else that's causing a problem. But I'm gonna get rid of what I tried to abstract this wait function, because it seems to be doing some weird stuff. Maybe it's not. Maybe it's actually working completely fine, but I don't know. This problem just kind of seems like a problem like this. So I'm gonna try one. I'm gonna try see what STL does do with 0 delay. Okay, it does just straight return, so that's not the problem. Even with a -3, let's try that. That hangs. Oh, because it's okay. If I say from integral, yeah, that's still bad. Yeah, okay. So negative is bad. We do have to have a max here. So negative is bad, but 0 is fine. Anyway, let's give this a go. I've gotten rid of all my dodgy delay. That's a problem as well, actually. So it's not my weight. There's something going on there that's really annoying that something's going on here like that. I might have to. Delay is basically a thread delay, except it uses SDL. I'm not sure what the difference is, but I think there's a difference there. It uses the C API is SDL delay. I don't know what the difference is, but it does use uses that, and I'm just using that because I feel like SDL's delay should do the right thing for SDL, even if it is just the same as thread delay, basically. Might have to like enable GHCI as a debugger and actually step through the code. A lot of people don't know how to do that with Haskell, so that could be actually like a good thing to show off. What line's this? Line 117. I can never really remember how to do it, but okay, so we hit a breakpoint. Stepping through. So we should see like a blue screen in a minute. Hopefully. Oh, we've stepped going pretty. Oh no, render rectangle. Okay, we're still going through. Okay. Whoops. Internal error allocation of however many bytes too large. Interesting. Are we allocating too much memory? Maybe that's the problem. Maybe we're allocating too much memory. I mean, it's good here that it's actually saying something useful there, but I don't think we're using too much memory, but maybe we are. Sometimes it works. Sometimes it doesn't. Is it like my computer trying to access a heap or something? I don't know what. Like, I mean, I've been really inefficient with my allocation and that. Like, I've been allocating like a heap of arrays and that, so it's quite possible that I'm allocating too much. Yeah, here, this is the problem though. What happens if I just wait? Will it eventually go? I did hit that. So I'm gonna try something. I'm gonna comment out my rendering of a sprite. Wonder why I don't reload there instead of relinking. It runs a little bit slower in GHCI because it's interpreted. You can actually notice a little bit. The chunks loaded thing is a little bit slower. It's not that bad, but you do notice it. Okay, so it's not just my sprite. It's not my sprite that's the problem. It's not just the sprite that's the problem. So I'm not rendering the sprite anymore, and still a problem. Let's comment out the textures. I didn't change anything around the texture. I didn't really change anything around much of this. So like, I don't know. I'm gonna put a delay in here. I'm gonna have a constant delay actually. That's something to try out, but I'm not sure if it is a delay. Okay, so it works without the other textures. Okay, so it's like now that I've commented out all the textures of the level, it's running pretty much every time it seems like. So I have a feeling maybe it is to do with the massive allocations I'm doing, which is a bit annoying. I'm gonna have to like start profiling the memory and figuring out exactly where I'm like allocating. Like it's probably pretty easy for me to go through the. Oh, hang on, it stopped again. It did stop again. So it rendered like one frame, and then when I tried to move around, it stopped. So now I can't move around. So it did actually stop there. Okay. So I don't think it is. I'm running out of too much memory. What I'm going to do is replace this with a constant. I'm going to replace this with I'm gonna assume that it takes 0 seconds to render a frame. I know it doesn't, but I'm gonna assume that for now and just pretend. There we go, we'll go 33. So we'll delay for 33. Every time. And we'll just work on the assumption that it takes less than 1. Like, cause it's, I mean, we're flooring it in a way, so it's like we have to be nearest to the millisecond or whatever. So it's like, let's just assume it takes less than a millisecond to render each frame, which it probably does. I have a feeling that's my delay. My delay's giving me a weird number, and then SDL's doing something weird with it. But then again, we already did test it out with 0, and it should only at most get 0. So like, it can't be that, can it? It's rendering fine. Could you not listen to dubstep, please? It's not my favorite music either, but it is. The people that the label behind this music is Monster Cat, and they use a bit of Haskell, so I'm supporting them because they use Haskell. So I'm sorry if it's not really your taste, but there's a good reason. This is working pretty much every time, so maybe it is a delay. Maybe it is that delay then. It seems it's running. Wish I had like a consistent way of triggering it every time, but I don't. It seems to be working fine now. Maybe it's the delay that I had. I mean, I just came up with coming up with a huge amount of memory. Maybe it's just like the thing is that when I actually compile and do a Cabal run right now, it's actually compiling it. When you use GHCI, it's actually interpreting it. So there is a difference between the interpreter and the compiler. So when I run GHCI, it might be allocating more memory than when I do a Cabal run, and that's why it ran out of memory when I was debugging it. So it's like that might actually be unrelated to why this is weird. I actually think this is the delay, because now that I've got a constant delay of 3, everything's fine. Now that I've got a constant delay of 33, it actually just renders every time, doesn't it? Whereas before though, I had this, but I thought this was fine because I was printing it out. Could serializing and saving the chunk data once for faster start, maybe. Yeah, that would be ideal. There you go, 0 and it was hanging. Sorry, I don't have a GitHub thing like that. I should get one because that'll be good. Hey Aman, how's it going? So 0 caused a problem. Okay. Zero caused a problem. Okay. It is it's a problem with the delay. I was right all along. Yeah, I was right when I said that delay 0 hangs it. It doesn't in the REPL, but it seems to run it. It seems to hang it when I'm running it like this. So there's something going on there. The times that I've run it now, it's like every time it's come up 0, it's started to hang. So there I've replaced it with 1, so it's got like a max of 1, so like if it tries to... We're debugging, like sometimes when the game starts it hangs, and I'm trying to figure out why. I think it's related to this delay I've got in here. I've got a delay in there to try and limit the frame rate to be 29.97 frames a second roughly. The same frames as what a Genesis or a Mega Drive has. And every time I start it, like, often when I start it up, it hangs. So here we go. It hanged and it said 1. There you go. Okay. I'm gonna say limit. I don't know if it's gonna fix anything. Maybe it's not gonna fix anything. Starting to learn Haskell in your studies in the upcoming week. Is it a hard language? I already know some Python and JavaScript. It's completely different from Python and JavaScript. So you will find it hard to learn if you are expecting it to be like Python and JavaScript. If you forget everything you know about Python and JavaScript, it'll be easier. Learning anything new obviously is hard. So like, yeah, learning Haskell is going to be hard for you. It is going to be new. So yes, Haskell will be hard. I'm gonna go back to that, so on my machine, it looks like the average is about 30, 31, 32. I'm gonna go 31. I'm just gonna go back to a constant. Hopefully running it for a while. I'll not see it again, and then I don't know what then I'll have to debug it again if I don't see it again, I guess. I'm sorry, it is going to be hard to learn Haskell, just because it is different from Python and JavaScript, significantly different, so it's basically learning something from scratch. It's super practical though, it's extremely practical, so like, it'll be worth learning. If you're going to program a computer, it'll be worth learning. The killer app for Haskell is programming. Okay, I'm going to stick with the constant delay, that seems to make things better. I have no idea why, but every time I load it up now, it's fine. I have no idea what's going on. I really have no idea. I really hate this constant kind of delay, but I don't know why that is being weird. Yeah. Like Haskell is easy and simple, but it's just like learning anything new. It's hard. Like it's only because it's new that it's hard, not because it by itself is anything difficult. Maybe delay has to be around a number. I've tried 1, I've tried 10, and I've tried 0, and they've all caused problems. So I'm not sure. I did do like oh thanks for these bits. Thank you so much. Yeah, so I've tried like capping it to like a minimum of 10, a minimum of 1, and for some reason like they are round numbers, so I don't know. Do you think Haskell's ecosystem and tooling are production ready to build like a web app using Yesod or something? We have in production, I work on Atlassian Marketplace, and in production we have a web app that uses, I can't remember what it uses, maybe Scotty? I can't remember. Let me have a quick look at another window over here. It's proprietary code, so I better not show it even though it's nothing special, but take me 2 seconds to figure out what it's made out of. It is made out of I can't recognize any of the libraries quickly off the top of my head here. That's a really good question. I don't know what this library is using. Oh, it's just using Warp directly. Oh no, actually it is using Scotty. So it uses Scotty. Okay. Yeah, so in production we have a Scotty application. That's what I'm trying to say. Marketplace.atlassian.com is using a Haskell application. Like this is not served by Haskell, this is served by Scala. But there is a part of this that is running and it's used as Scotty. So, I mean, sometimes when you do things on the website, you'll hit that indirectly. You're kind of like, it's kind of more of like a logging, or it's basically a service that tracks analytical data and that. So when you're hitting this, you'll be hitting some Haskell, depending on what you do. But certain parts of this app will hit Haskell code, and it's actually a Haskell web app, and it is far more pleasant to work with the Haskell code than to work with the Scala code for Atlassian Marketplace by far. I would highly recommend using. I don't know about Yesod. I don't really use Yesod that much, but there's a lot of different web libraries in Haskell, so yeah, I highly recommend looking into it. It's very good. Why is the resolution of the screen so small? Just so people can read it. I see it very small on my screen, but it will be massive on your screen, and hopefully that means you can read it. Can I ask you to explain the layout of the Cabal file, specifically about the executable library sections? Okay. So I have in this app, in my Sonic thing, I've only got an executable at the moment. I should separate it out into a library. That'll look like this. Oops, I'm all over the place. So the sections mean, so I've got a library here, right? Let's just pretend that I've done this properly. So this library is code that I can use from other packages. So if I have like I've got three libraries I want to use, that I have. I'm making 3 libraries. This is one, and then I've got another one. I can actually depend on this library. If I've got another library, I can depend on another library. Or if I've got an executable, I can depend on a library. So there's kind of like a little bit of a hierarchy where libraries can be used or imported from other things inside of Cabal. So you can have executables, test suites, libraries. I think you can have benchmark suites as well. Maybe there's another one that I'm missing. But yeah, you can. Oh, thank you so much for those bits. That's wow. Thank you so much. Thank you. I highly recommend learning Haskell. It's a lot more simple than Scala. So at work I teach Haskell a lot, and that's because it is the easier one to teach. It's definitely the easier one to teach. When you do Scala, it takes a long time to There's a lot of apologizing for things, and it's also very hard to explain functional programming in Scala because there's so much in Scala. It's a massive language. Compared to Scala, it's completely different. Like Haskell is very small, Scala is massive. So if you're worried about learning, like if you already know Scala or you already know Haskell, ignore what I'm just saying. But if you're interested in, like, if you're trying to figure out what to learn, you'll have a lot easier time learning Haskell. It's completely different. And I teach Haskell at work, even though majority of our applications in Scala. I teach Haskell at work because Haskell is useful first of all, but secondly, it's so much easier to teach functional programming in Haskell. And some people at work, kind of they want to learn functional programming using Scala, but I think they recognize now how much of a difference it is between Haskell and Scala for doing functional programming. Yeah, but it runs on the JVM basically. Yeah, that's Ed Komet's quote. He had like 20 different points about why Scala is not great, and then at the end he says, but it runs on the JVM. So getting back to the Cabal file. Okay, how do you make your executable depend on the library, and which build depends do you write external dependencies in? Okay, so you put build depends in the library, and the executable if you actually use them in the executable. So to depend on the library, you add it. So let's say I've got the library and I've done all this exposed modules, and so my library actually has all of this code in it. I can come down here and I can say Sonic 2. And this actually means the library, because when you put things in build depends, you're actually depending on the libraries. You can't depend on test suites, you can't depend on executables, you depend on libraries. And also there's a weird limitation at the moment, which is that you can only have one library per Cabal file. That is going to be, someone's actually working on that as Google Summer of Code project, so someone's going to make it so you can have multiple libraries in the Cabal file, which would be awesome. But at the moment you have one library per Cabal file, so when I say Sonic 2 down here, it's unambiguous, I mean this library up here. So that's how to depend on the library. So I've got this executable, I can depend on it, and this is, yeah, this build depends probably should actually move up here. So my build depends should go up there, but down here I'd also have a build depends, and it would depend on not everything that's in the library, but it would depend on so Sonic 2, and then base, it would depend on everything that the main.hs also needs directly. So main.hs, look, it needs lens, so I need to add lens in there. It needs this is in either transformers or MTL, I can never remember which one. It needs my bounded library. So anything that you directly import in main needs to be added to the build depends as well. So basically this is just a list of things that you actually use in that particular section. So in library, you put in everything that your library code uses, anything that it actually imports, and in build depends for executables, you put in whatever your actual main.hs or whatever your actual code for your executable uses. So you don't put anything indirectly, you put only things that are directly used. There is a little bit of a weird thing. If you have a library and an executable, I highly recommend. Is a HS source directory or something like that? HS source, yeah. Highly recommend setting this. So if you have a library and an executable together, make sure you set HS source directory and have like, so library, and then put source here. Like just have like all your library code under source, and that's so that there's a reason for that, which is that if you have a main.hs and you import game.sega.sonic.tiles, for example, here, it'll actually look up here. And so instead of if you have a build depends and you try and depend on Sonic 2, instead of using the library, it'll actually just use the file that it finds. So it'll use the file ahead of using the library. It won't use the library if there's a file that has the same thing. So that's why you should put it under source, because then if you don't have the same HS source directories for your executable, it won't automatically find the files that you have there. So the difference between exposed modules and other modules. Exposed modules are stuff that you can import. So if you have a library and you got another library, so you got library A, library B. Library B can import everything from exposed modules of library A. So if library A has other modules, you can't import them. That's really the only difference, that you can import them or you can't. Exposed means you can import, other you can't. So it's kind of like private or internal stuff. In Haskell, we actually have like a kind of like a convention to like actually, like, so other modules in executable are actually, so sorry, there's other modules for executable, and that is like executables can't have exposed modules. So you don't, like, if you're using a library, don't use other modules, just expose everything. That's kind of like a pretty good convention in Haskell. But other modules for an executable is just to define things that you don't want to, you can't export things from an executable. You've only got a main file. You can't consume an executable. The only way to consume an executable is to run it. So hopefully that explains that other modules is just there so that you can use them. If you don't have it here, Cabal will not have a good time with finding the files and using them. It will basically give you a warning. I think it actually still can find the files, but it'll give you a warning. So you just use other modules to just put the things in there that you can use for main, but you probably don't want this. Anything in other modules probably should go into a library. Like, I've got this thing here, other modules. All of this stuff should actually go into a library. And I should expose it all. Like, there's no, like, main, I should really have main be like main equals game.sega.sonic.main or something like that. Like, really, there should be pretty much no logic in my main. I'm doing a really bad job at the moment, but ideally I'd have library and I'd have pretty much everything in that, and it will be exposed and it will be consumable. There's no reason for me to hide it or prohibit anyone from importing it. And my main should just really be just calling a main function that exists in the code. I should really just be consuming things, but that's how I think that all Haskell libraries should be made. Ed Komet does like a really good talk against encapsulation. Well, maybe it wasn't against encapsulation. It was basically against information hiding. He said, don't hide information. Expose everything, and let me have access to everything. You know? Encapsulation or information hiding kind of works against code reuse, and code reuse is super important. He has kind of like a rant that you can look up online somewhere. It's like Ed Komet. Yeah, here we go. Encapsulation versus code reuse. Yeah, he goes on a bit of a rant. It's pretty awesome. I highly recommend. It only goes for like, I don't know, 20 minutes. I think he's ranting or something. Yeah, I think is it the OpenGL library? Yeah, it might be the OpenGL. He's got his own OpenGL library now because of that rant. It's entertaining at least. Okay, I'm gonna try loading up Tails, and then I think I'm gonna call it there. I think that's where I'm gonna finish up. Gonna try having 2 sprites at the same time. Let's see how that works out. There'll also be some stuff that I need to like abstract between that, like the loading of a character should be something that I tricked away. I think I had Sonic about there. Yeah, exactly. You've read something about him complaining about libraries not exposing enough stuff, so he's unable to change them meaningfully. Yeah, exactly. Yeah, so I think he'd be on my side to say that the library should not have any other modules. It should be like all exposed modules. And a convention is to like put .internal for things that you don't want people to access. Like, so instead of actually like, you know, not exporting them, you just say it's a .internal, and then say, hey, if you access it, your own fault. And then you get commit, who actually will go and access it and then do something pretty cool with it. Hopefully. Yeah, he's ranting against the OpenGL library, I think. And so he's got his own library that does it now. Okay. Got Sonic. Looks like he's half standing on the ground. He might be half in the ground. And he animates. Next step, I'm going to get Tails to do the same thing. This will show, I'm just going to do copy and pasting, and this will show what we need to fix up. Actually, I don't know if I've got Tails as animations in it. I don't have Tails as animations. Is the music still too loud? Okay. Hopefully that's better. Is it worth it to learn NixOS if one is willing to do the work? Absolutely, 100% yes. If you are willing to put in the effort, it has paid off for me by far. I like what I was showing before. Marketplace completely deployed using Nix. So it's technically not NixOS, but I mean NixOS is a really good way of learning Nix because you have to learn Nix basically to use NixOS. It's very hard to use NixOS without learning Nix. But Marketplace is all deployed using Nix. Nix builds all these Docker images and we ship them off and that to our internal platform as a service. But it's all Nix, 100% Nix, and it has paid off a lot because anything I push out to production, I can build on my laptop, and that is really cool. I can do a Nix build and I get exactly the artifact that I've pushed out to production every single time. Even people on the Mac, they can technically do it, but yeah, because I use NixOS, it's super easy for me to build exactly the artifact that I'm deploying to production of all of our services. We've got like 5 or 6 services that we deploy to production, and every single one of them I can build on my laptop because I use NixOS, and it makes it really easy. And I could technically do it on a Mac, or I could do it on any other Linux, but NixOS makes it super easy. And it's also a good way to force yourself to learn Nix, because you have to. You basically have to know Nix to learn NixOS. Sorry. Did I say that right? Learn Nix to use NixOS. You're limiting yourself to Cabal while I get up and running with Haskell. Since I'm fluent with Haskell and it's idiosyncronies, I'll do next. Oh, once you're fluent. Okay, yeah. Yep, that's reasonable. Nix is quite like the thing is it is a big effort to learn Nix. So like, it probably took me. I mean, it took me a lot of months to get really good with Nix, or to get you know okay with Nix. But it has really paid off by now. It's a lot like Lens. Getting good at Lens was an intentional investment I made, and it's paid off a lot. Yeah, it's paid off a lot. So I don't have. I just realized I don't have the mappings for Tails. I don't have the mappings. I don't think. Because what I did recently, I don't know if I went over this yet, but I got rid of. We were using S2 disassembled, like the disassembled version of Sonic 2. I got rid of that because it didn't have disassembled animations, and so the only way for me to get animations was either to copy and paste it from the actual assembly, basically copy and paste all like the actual numbers over, which would be not great, or I had to index into the ROM, and so I indexed into the ROM because that's basically the option that I chose. I didn't want to have to copy and paste animations over when all the art and everything else is coming from the disassembled ROM, so I just decided to just use the ROM. And yeah, so I deleted all the disassembly stuff, and now it's just using the ROM. It's just these are all just indexes into the ROM. So yeah, so everything that you see is actually being loaded from an actual Sonic 2 ROM. An actual ROM file. And you know, the logic of me moving the camera around that's all done in Haskell, but the art and the animations and everything else is coming straight from the ROM. The levels, the collisions, everything's coming from the ROM. The palettes. So I need to figure out the animations and the mappings for Tails. Here we go, Tails mappings. Okay, cool. So they are there. I remember seeing them on their website before. I remember finding Sonic's on there. So it's good that they've also got Tails. I don't know where it ends though. I'm not sure, like, so it's a 6400, okay. Maybe Tails will be roughly the same as that. Maybe that's a, I don't know, I was just trying to figure out, like, is it like a roundish number? Is it like a, I don't know, is it like a number that has like some sort of like boundary or something like that? Maybe it's some sort of constant sized mapping thing. So I'm gonna pretend it is. Or make the assumption that it is. We'll see. So that's the mappings, and so we've got the mappings, and so where's the art? I need Tails' art. Here we go, Tails. Hang on, it's the mappings though. What's that? Hang on, what? So it's got Tails mappings there, but then it says Tails down here. That's interesting. Why is there two Tails? Don't know. So that's where Sonic is. Where's Tails? Okay, Tails starts there. Okay. I should probably actually look at the disassembly. The disassembly will have all of this data. I'll look at the disassembly. The disassembly will actually tell me. This is something that actually... So it won't tell me the animations. I'll have to... I don't know what I'll do with the animations actually. I actually just... What I do for the animations, I actually just looked at the disassembled version and then just searched the actual ROM for that data. I can do it again. I'll do it again. It's easy. So Sonic's offset is 50,000. There we go. So these are the, there we go. So Tails is that. That's what I should be copying and pasting in. So that is different from what that website said. Okay. This is Tails' mappings, which is also different from what that website said. Okay, but hopefully this is right. Hopefully this is... Yeah, it should be right, because that's what it's actually done. Okay, it should be right. And now I just need the animations. And the animations are actually in that ROM that I had open before. So we've got Sonic Run. Run file. Not there either. It is in here. Sonic Run Sprite. Son Annie Run. So maybe there's Tails Annie Run? But I want the idle. So there's actually yeah, that's something. So I need the Tails weight. I'm going to use the weight animation. I actually specifically chose the weight animation for Sonic because the animations for walk, run, and I think roll are all dependent on how fast Sonic is going. So if you try and play those animations, they're actually corrupt because they've actually got special code inside of the ROM. So actually, I was reading the disassembly, and they've actually got special code in the ROM that discards half of the animation data. Well, maybe not half, but it discards a couple of the parts of the animation data and has its own special stuff, special logic about which frames to show when. And it's based on like your like inertia against the ground and stuff like that. So it's like if you are kind of going slow, Sonic's frames will slow down. That's different from like the weight animation where he'll just play it it'll just play at a speed. The speed doesn't depend on anything. So this is the weight animation for Tails. So you can see it's like 7 1 1 1 1 1. So this is what I need to find in that ROM. So in my ROM, I need to find that. I had to what program did I use? Was it bin walk? No. I used a program. What was it to find out? What's that? No. Maybe I used it on my my other laptop. It might have been bin walk. I used a tool that like basically it was basically a binary grep, and supposedly grep can kind of do binaries, but it doesn't do a great job. I think it was binwalk. I'm gonna compile it and have a go. There we go. We've got binwalk. Say \7 \1. Actually, I might have to do, is it X before each one? How did I use this? Does anybody else ever used binwalk? I'll figure it out. It'll just take me longer. If someone's used it, that'd be awesome. Maybe it wasn't binwalk. This is when my small resolution becomes annoying for websites that suck like that. Yeah, I think I'm looking. Yeah, binwalk is for finding firmware files. I'm looking for something else. Oh no, binwalk. It is binwalk. I am looking for binwalk. -R. So it is for finding files in firmware. There you go. So there's 2 locations that has that. So I think Sonic's and Tails' animation is too similar. So I'm gonna go, what is 8786 FE1C 8 7 8 6 FE1C. There we go. Cool. So that's found the animation inside the ROM. So I'm gonna load up the ROM. This is copywritten stuff, so don't copy it. Don't copy it. It's illegal. And we're going to copy in this. I'm going to go to that location. So there you see the 807. So the animation started with a 701, didn't it? So right here. What's this location? It is 1D0A2. And its ending location is 1D0E0. Cool. I should script that and actually make it more useful, but that's what it is. I don't have a device with a small resolution. No, I have two 23-inch monitors, 24-inch monitors. So no, I've set it up like this for streaming. On my screen, it's very tiny, but for you, hopefully it's readable. Okay, so I have Tails' animation. I'll need to find this, the DPLC for Tails. Well, I really want to get Tails rendering, and then I want to go to bed. So that's my goal. Get Tails rendered, go to bed. 71E0. No problem. Yeah, it's good that yeah, it's the weekend, so I get to stay up late a little bit and do this. I actually did intentionally kind of stay up so that I'd get some European and American viewers, so that's good. Okay, and what's the end location? I'll just look at the size of this and add that on. I really should be, you know, I should really have like a heap of scripts ready to do this sort of thing. But I don't have that. What do I do for my main job? I am a well, up until recently I was a site reliability engineer. I've been hired as a senior software engineer, but I kind of transitioned into a site reliability engineer for a little while. But we kind of got rid of that. Everyone is now responsible for the reliability of our website. I work on this specifically, Atlassian Marketplace. So it's kind of like the App Store, like an App Store, but for Atlassian products. So like if you use Jira, Confluence, Bitbucket, Bamboo, Stride, any of our other apps, you can come here and install add-ons for that. So I work on this. It makes a lot of money actually. You can Google. There's a lot of press releases that come out and say how much money it makes. It's like a hugely successful part of Atlassian, and I work on that team, and it's a pretty good team to be on. We get to use. Get to do functional programming all day because that's what it is. It has been functional programming since 2010, I think it was first started, and it's been Scala Z since then. It's been Scala and functional Scala since then, so really good. Maybe my volume's decreased just because I'm wearing out. Sorry if it's been my end. I feel like maybe my volume did decrease. Did I get it further away from the microphone maybe? I can get it a little bit closer. My volume is low compared to other streams. Okay, I'm gonna adjust my microphone very slightly. Hopefully. Okay. My microphone should be a little bit closer. I don't know if that helps or not. Okay, hopefully, I don't know if that's better, but hopefully it is. Let me know. Okay. So I think they use the same palette. I think Sonic and Tails actually are in the same, yeah, I'm confident they're in the same palette, so I don't need that. Did I not have the mappings? Oh, I'm just missing an S on that. Never seen Haskell before? Well, I'm not doing a great job at showing exactly what's good about Haskell, but hopefully you're interested at least. Come on, it should be found. Mapping tails, mapping tails. Mapping, oh, mapping's tails. Whoops. Mapping tails. Mapping tails. Okay. And I'm going to do this. Code duplication, and hopefully hopefully next time I can get rid of this duplication. It's all, I like writing out the duplicated code, making sure that it is exactly the same, and then removing all the duplication. Okay, so I've got all these textures now for Tails. So now I've got a Sonic Sprite, and I'm going to add a Tails Sprite. And Tails is going to be 50. And hopefully I don't run out of, hopefully the problem isn't that I'm running out of memory, because me loading up Sonic and Tails is probably going to be way too much memory if Sonic by himself is too much. Okay, got Tails, got Sonic, Tails, add him to the actual game, Tails. It'd be good to go back and actually remove all this duplication. Really what I should have is like a list of sprites to display and update. Okay. I think it compiles. Who's ready to give it a go? Anybody itching for me to press enter? Let's give it a go. If this works. I can go to bed if this works. Alright, let's scroll down and hopefully, whoops, if I actually press the keyboard, hopefully we'll see. There's no Tails. Why is there no Tails? Why is there no Tails? You know why? I didn't render it. I didn't render Tails. That would help. It would help to, you know, to actually, like, you know, render Tails. You know, render Sonic and maybe render Tails as well. That would be good. Okay. Hopefully this works. Come on. So it's 1:30 in the morning now. I usually go to, I usually, like, so I work, I've got a story before we actually figure out if this works. I work for a company in San Francisco. Well, I work for Atlassian, which is, you know, an Australian company, but my team is in San Francisco. And so I usually wake up about 5 or 6 to start work. I mean, I work from home, so it's like, you know, I can start work within 2 minutes. Well, as soon as I wake up. But yeah, I work for a San Francisco company, San Francisco team. So usually I'm up really early, and I usually go to bed pretty early. So me being up at 1:30 is pretty rare. Let's see. Look at that. How awesome is that? I am super happy with how that looks. That is really, really cool. Both Tails and Sonic doing their waiting animation, and the code wasn't that duplicated. You know, I'm copied around, like, you know, the offsets and the loading of the offsets and that, but that's super easy for me to, you know, abstract away. You know, well, it's not even abstracting away, it's abstracting, putting them into a function. And in Haskell, you know, making a new function is not a problem. Does it leak memory? Almost certainly. Actually, when it's animating, I don't think it actually does leak memory. It uses up a lot of memory, but it doesn't. It uses up a lot of memory. I don't think it leaks. I mean, you know what? I'm gonna leave this running. That is the full item. Oh, so you did miss because I was telling my story. You missed the beginning of it. There is actually slightly more to that animation. That's the ending animation. Sorry, the end of so it loops like the last 6 frames. So you can see here, see Tails is blinking, and they're both just standing still. Sonic's getting annoyed. Tails looks at ya. So the whole idle, like the waiting animation, actually takes, you know, a couple of seconds. So I don't think at runtime, yeah, it leaks memory. It leaks memory at startup because it allocates a lot of memory. It actually allocates most memory onto the graphics cards. But because this is, you know, tiny sprites, I don't really care. We do allocate a lot of, we allocate, like, all of Tails' animations are loaded up in memory. Maybe not all of his frames are loaded up in memory. All of the textures, like, they're all rendered in memory at the moment, on the video memory, but you know, it's a 2D game. It's not, I don't think it's a problem. But we do allocate a lot. There's also a lot of arrays and stuff. Some of the arrays would have got garbage collected, some of them might not. Well, probably not. So there is memory enhancements we can do. There's a lot of stuff we can do to decrease the memory. But anyway, I'm happy with this for now. I don't think while it's running, it's going to be using up more and more memory. But I'm going to leave this running. Actually, I'm going to just leave it running. Why not? I'll leave it running, and I'll see tomorrow if my computer's still running or not. Atlassian does use Haskell. On my team, we do, like, on the marketplace website, there is a service. So we've got like 5 services that are deployed. Thank you, Freeman. Thank you so much for those bits. Thank you so much. So Haskell does use, Atlassian does use Haskell. We've got like 5 different services that make up Atlassian Marketplace. One of them is written in Haskell. It's not the most important. Like out of probably the 5 services, it's probably either like the least important or the second least important. If it goes down, we'll try and work on it soon to bring it back up. Like it's not like, hang on everyone, we need to bring this up now. It's not completely mission critical. It's just, it's a thing that we use for analytics and stuff. So we'd lose some analytics and some people would be unhappy, but it's not completely mission critical. So in terms of like actually serving like end customers, no, Haskell isn't really used there, but Haskell is being used when you hit this. Haskell is here collecting like analytics and stuff. So we do use Haskell in production. The biggest use of like Haskell for Atlassian Marketplace is actually like more in our build tools and our chat applications and that. Like when you do a build in for Marketplace, we got like chat notifications that come up in our chat rooms and that. So we use Stride, which is an Atlassian product, and all of the bots work with use Haskell. So all of our bots that talk like between Bamboo and Stride. What else have we got? We got Bamboo and Strides. Oh, we got Bitbucket and Stride. And yeah, Bitbucket and Stride. We got all these integrations between our products, and they're all written in Haskell. So most of the people that will be touching Haskell probably wouldn't be so much on the actual website, but on our bots and our our integration tools. Cool. Thank you, other troll. I know who you are, so that's fine. You're not a real troll. Okay. I'm going to leave it there. I'm happy with what we've got, and I'm going to leave it running. When we'll check if there is a memory leak. I think this is fine. I don't think so. I think looking at this, I don't think we're actually leaking memory or anything. I think it's just, I think it's fine. But we'll see. Should be fine. I'll think this will be running tomorrow, and it'll be good. So tomorrow, I might stream tomorrow if I've got time, because I want to do the next step, which is to remove this code duplication I've got, because this is gross. So hopefully tomorrow I can stream and we'll do this stuff, and we'll abstract it out so you can load Sonic and you can load Tails with like 1 line of code, render them both. And then I guess the next step is to add in like management of sprites into the game. So like it has like a list of sprites to render, and it renders them all. I think these flowers. You see how they're all yellow? That's because we don't have any textures loaded for them. And I think if we did have like that thing of like going through and a list of sprites and rendering the animation, because I think these are animated. I think that's the thing. Like these are animated sprites that should be shown in these yellow spots. I definitely know that the flowers are meant to be animated. So wherever a flower is, yeah, here we go. So I think that's meant to be like an animated sprite. And so since we've got Sonic and Tails being animated sprites, should be able to also have some animated flowers on, which would be cool. And then we've got animation and sprites, and I'm pretty happy with that. I guess what the next thing would be, after we like do some more on this animation, would be to actually get them to move. I'd like to see Sonic and Tails move. Cool. So tomorrow, maybe I'll come back. I think I'll have time tomorrow. So tomorrow night, I might come back. Actually, it might not be tomorrow. Yeah, because that'll conflict. So I'll probably do it tomorrow afternoon for me. Probably stream again in 14 hours. Something like that. Okay. stream again maybe in 14 hours, sometime around then. I'm not promising anything, but I'm gonna try and do maybe 14 hours from now, and we'll work more on this animation. Okay. I'll probably upload this to YouTube as well, because it's been pretty good. Got through a bit. Sucks that I spent so long debugging all of that. Weird error where like things wouldn't load properly. But anyway, we got through it. It's dodgy, but it works. Okay, cool. Cool. I'll see you tomorrow if you're around. And yeah, it's been awesome. Thanks for staying up with me. I'm actually gonna go try and find someone else who's streaming. I've got this functional community, and here we go. We got more than one person in here. Okay, someone's using NixOS to play Counter-Strike. So, I think they were actually writing Haskell before. So I don't know. Maybe we'll find something a little bit more relevant than Counter-Strike. Yeah, you should join that Art of the Troll. You should. Visualizing matrices and transforms for game dev, maybe. Who can we host? C Lua, yeah. Okay, I think we're gonna go 2D platformer. That's somewhat relevant because of what we've been doing, but I like to stream. I like to host people that do functional programming. So. Do you use hashtag functional for the string to appear here? No, there's like a setting you can do. You can do like when you have like in your settings you can configure communities. You get to list like 3 communities or something. So if you list them there, it'll come up. I think it's in like you just change your settings and you change it. Settings and it comes up communities. You type in functional programming. Okay, we're gonna go to this guy, Tom Baudet. Hopefully Baudet. Tom Baudet. We're gonna go Tim Baudet. Okay, say hi to him. I'm gonna go to bed straight after this because I'm tired. And I'm happy that we got this Sonic thing. So say hi to this guy, and I'll see you hopefully tomorrow. If I can spell his name.